Welcome back to our panel discussion, Computer Vision, Expanding Tomorrow's Mission-Critical Capabilities Today. Sponsored by Dell Technologies here on Federal News Radio, part of the Federal News Network. My guests today are Jeff Alstott, a program manager at IARPA, Chris Algier, Federal Director of FirstNet, Stephen Dennis is Director of the Data Analytics Technology Center at the DHS Science and Technology Directorate. Michael Knight is Global CTO for the Industry IoT and Edge Business Unit at Dell Technologies. And John Garofalo, Senior Advisor for Programs in the Information Technology Laboratory at the National Institute of Standards and Technology. I'm your moderator, Tom Temin. And let's talk about getting started in this new world of using all of this data, all of this video streaming to get around in front of problems instead of always reacting. And you do need basic foundational architectural and other policy blocks in place. And so Michael, why don't we start with you with what are some of the ground base needs for getting into this new world?
Sure. I think oftentimes we all start reactively is something occurred, I need to put a sensor there. Now I have a sensor there, I have to collect the data. Now I have to collect the data, I have somewhere to store it. I have somewhere to store it, I have to refine it, then I have to get that out somewhere to do that. What's interesting, it's pretty analogous to the oil industry, right? I'm pumping crude and I got to move it to refine it and refine it to production, those types of things. So one of the things that, if you can take an architectural view of that, and you can look that thin edge, that sensor, up to your multi-cloud or where your analytics may be occurring, and also from that top back down. I think if you look at what you want to achieve, so we'll talk about it as an outcome, sometimes that word's a little overused, but in this case it's the right use of that. What are you trying to achieve? And if it is, I want to be able to make my city or my environment more safe, then I have to know where the sensor points that I need. But in order to do that, how do I need to deploy those? How am I capturing the information? Where do I store that and analyze that? So one of the things that we think is critical there is you certainly have to have edge compute. That's going to be where a lot of that information comes in first. You have to have the right types of sensors and communication back. Refining as quickly as possible, so there's applications and architectures for that, and also to be able to keep the environment not only healthy, but also to continue to orchestrate and deploy new things in the future. And so what our perspective is a scalable architecture from that thin edge to a multi-cloud strategy that enables customers to make different choices, right? We hope and pray that they choose Dell Technologies for a lot of that, but we know that oftentimes that there's different choices they make along the way. But it's our architectures and everything else that's, I think, is pretty impactful. So if they look at it from a design standpoint, knowing what information they need to collect, how quickly they want to refine that, and then be able to produce an outcome from that, that's an important thought process for that. So if you do a mind map, I think that's a good way to start.
Yeah, so the idea of fast and getting over the latency that we talked about earlier, the transmission times, that's really a critical part of that architecture if you are going to be proactive in situations revealed by the IoT, correct? Anybody?
No, absolutely. Well, I was going to say, so as we start looking at where we're going from a technology insertion from a network perspective in the FirstNet network, is the applications of mission critical services, push to talk, voice being the sort of initial entry, but mission critical video is on its way. And so there are latency requirements that the standard has in play that we have to look at and how we implement that in the network. And then how do we start, to your point earlier about from the sensor or the device up to that computing power and back, how long does that take, right? Does it have to exit our network to go someplace else for that to occur and then back? And so how do you ensure the timeliness of the information operationally, as well as from a standards perspective and safety of life in certain instances where that bit of information just needs to get back where it started from as rapidly as possible?
John?
I think we're starting sort of from our baseline is cloud technology, which sort of transformed the way that we work with large amounts of data at rest for non-time critical applications. And now we're adapting that model for real-time, life-critical applications. And we've talked a lot today about how we're going to have to distribute the processing power. And that really is what we're going to need to do to address these challenges of having a specific amount of response times, both in the flow of information and in the analysis of it. So I think we're really going to be moving over the next 5 years into these highly distributed computing and data storage models that are going to look completely different than anything that we have right now. I think it's also going to require the creation of new types of positions and organizations that work with these types of applications that are real-time, life-critical applications. You're going to need someone who basically understands how to interpret the information and interact with the system and the users. So you're not going to, at least initially, going to be training every user, every first responder in the analytics. So you need an interpreter. And you also need folks who understand the technology side of it. So they're going to become sort of the pseudo data scientists of the use of this type of technology. And so I think we're going to see new kinds of positions being created to fill in some of the gaps for these real-time challenges.
Yeah, Jeff, what are some thoughts on the human capital side of this?
Yeah, so as John was saying, you really do need the two different sorts of human experts on this. You need the people that will be using the machine, and there you have to think of man-machine teaming, of how will these people's workflow get modified by the machine? Will they trust the machine appropriately? Don't trust it too much, don't trust it too little, and so on, and get the most value out of that. But then you have the people that help build the machines, right? And these two groups of people need to talk, or otherwise they will build the thing wrong. And unfortunately, talent management is always a problem, but in terms of the people building the machines, they're really at a premium right now. But this is just the the nettle that you guys have to grasp in order to solve this problem.
Yeah, and the other question is the machine you build that you're going to team with someone capable of getting coffee for the person you're teamed with? That would solve a lot of problems. But the other implication I'm hearing in this discussion is that you really need a very specific, not just a strong data strategy, but one specific to this type of application set.
Yeah, it was mentioned earlier by Michael that you sort of refine the data, that is in some ways like petroleum. So there's a meme going on right now that data is the new oil, which is not correct. Data is valuable, but unlike oil, you can't just get some oil out of the ground and then automatically use it for many different applications. You have to build a refinery around that data well that is built bespoke for that data set, right? And that's the sort of thing that Dell and others are really great at doing, but that is a necessary task. And so part of that is making sure that you're getting the right data, you're combining it the right way, that you're making sure that the data really represents your actual use case so that all the tests that you do reflect how it will ultimately get used. And that's the way that you need to be thinking about the whole process in order to get that value.
Yeah, I would say data is the wool and the loom, because instead of sort of the singular flow, this old process kind of concept of looking at the flow of oil or the flow of data, that it's now completely interrelated, and that there's no data that's really independent from other data, and the way that we work with that data is not going to be independent. So I think kind of like the loom is maybe a better representation.
We've got the warp and the woof going on here, I guess. Well, also with respect to that data, that also leads to the notion of architecture, storage, edge processing, because if, as you mentioned earlier, the cloud is the repository of data, no agency can afford to keep downloading and uploading a petabyte of data every hour when something's going on. So that edge computing and pre-processing seems to come into play also as part of the data and architecture strategy.
Yeah, I think that's true, and I think you have to conduct experiments now that tells you, what should your architecture be going forward. And you have a couple of cloud choices today. Tomorrow you may have more. What does it mean to do computation, leaving data in different clouds? So what does a hybrid cloud computation look like that's secure and privacy protecting? And then how does it marry to the edge? And what is your computational strategy over that entire architecture? But in order to figure that out, you really need to have your hands on those kinds of architectures and building up the talent base that's necessary in order to carry out this work. And I think you do need to consider other organizational structures than sort of the typical top-down structure that government likes in order to organize ourselves to take advantage of the data.
I think we'll also see new types of encoding of data.
Yes.
So right now we're just take data, we use some compression algorithm on it, that's basically focused on taking advantage of the perceptual weaknesses of the end users, whereas in the future there may be very little difference between how we compress it and how we represent it in terms of the analysis of it, so that we could be pushing extremely lean representations of the data around this very complex pipeline to reduce the load on the pipeline and to actually enhance the ability of the AI systems to be able to analyze it.
That's the type of data approach almost pioneered many years ago in fingerprint transmission. Where there's a
Exactly.
few data points that you don't need to send the whole file of every little line and whirl
Exactly.
in there, sure.
One comment just about, when you're refining, so use the analogy of the data lake. If you're going to refine the murky data lake, right, do you try to do that there as fast as possible, or do you go upstream to the rivers and streams? Right? Because if you handle it there more quickly, then you're getting a more refined result as it's coming in. Then you can learn more broadly across that. And those are some of the positions that when you look at the architecture, you are going to want to have high performance compute to do some level of things. And that's really kind of your centralized learning where you're taking that in. But if you're bringing in much more refined data that you're already able to use at the edge to make decisions on, and then as that comes in and then you can learn more broadly, there's also the notion, and because some environments they can't either afford or can't use centralized, right, for geographic reasons or geopolitical reasons. And that's where there's the notion of that federated edge, to where you can allow that federated edge to learn and refine and also build higher trained globally inference models off of that. I think that's something that can be compelling in these entities.
Yeah, because I think what you'll find is, especially in a public safety environment, that how rapidly that you're able to analyze the data and come to a decision point. But then what's the level of accuracy of that information, right? So sometimes you don't have the luxury of having to be able to reach back and have that analysis take place. So how do you put that on the edge? And then what's the confidence level? And then what's the right sort of talent pool that's out there, the level of understanding of the end user and the more technical folks in the field that are assisting in how they consume and operate and use that information. So again, I'll come back to that priority of the information is extremely critical, and then there are layers within that as well.
Interesting, because we hear often from the military domain that yes, cloud computing is important, but we have to have edge and local computing because we operate in austere environments where telecommunications may not exist except for very, locally. But what I'm sensing is this is also true in civilian domains across the government.
And I think it calls for introspection too. I think organizations need to understand what their maturity is relative to the ability to collect and curate data, also then to produce analytics on that data, and then for the decision-making piece, how good are they at making decisions, and then looking at the context. If you're shifting context, if you're in the military and you're austere circumstances, you need to be training, improving your maturity level around those scenarios.
Yeah, because that drone may download that data or that camera to that data locally, but the cloud will have to come later.
We talked about IoT before and even brought up earthquake and seismological sensors and sort of the difference between collecting that seismological data for scientific research that somebody's going to go and chew on in a lab somewhere, as opposed to seismological data that's being consumed immediately. Right. In order for responders or industry, right, to make a decision based upon, hey, shake alert, that system is out there. So how do I gracefully power down a system as opposed to just allow the earthquake to turn it off? So we're seeing that sort of transition where IoT is coming in and the immediacy of being able to have an action occur based upon a piece of data.
Interesting. And in the time we have left, we should just go briefly into some of the protections and cybersecurity concerns of this whole technology set.
Yeah, it's a very important point, Tom, because what we're talking about when we talk about automation is either taking a human judgment out of the process and saying, okay, we're going to automate that, or relying on a new automation point that we haven't used before. And automated systems are automated. They're going to take their inputs and do their outputs according to whatever their internal algorithm is, and that's it. And unfortunately, that is a thing that is abusable, right? So if you're trying to deal with a hurricane, say, the hurricane is going to do all sorts of things to your sensors that you may not have expected, but it's going to be sort of random, right? And so you can sort of have a statistical guarantee about the functioning of your system. But if you're dealing with an adversary who's a human being that's going to deliberately try to screw up your algorithm, now it doesn't matter if there's just one hole in your whole sort of algorithmic process. The adversary is going to go try to find that hole and abuse it, right? And so we really need to be conscious of these sorts of new security issues, where it's not a conventional cybersecurity concern of someone hacking into my machine, but it's an algorithmic security concern, where someone is abusing the automatic process by which we're using our decisions. So that can be ameliorated by good test sets, and at IARPA we're trying to develop new techniques in order to test algorithms in order to ensure that they're secure. And those sorts of new techniques are going to only be implemented by great people.
All right, so great discussion. We have to end on that note. Probably we could go on for hours, but we thank you. I want to thank today's guests. Jeff Alstott is Program Manager at IARPA. Chris Algier, Federal Director of FirstNet. Stephen Dennis is Director of the Data Analytics Technology Center at the DHS Science and Technology Directorate. Michael Knight is Global CTO for the Industry IoT and Edge Business Unit at Dell Technologies. And John Garofalo, Senior Advisor for Programs in the Information Technology Laboratory at the National Institute of Standards and Technology. I'm your moderator, Tom Temin, and you're listening to Federal News Radio, part of the Federal News Network. For more information on this discussion, visit federalnewsnetwork.com and search Dell.